All right, my last video was cut a little bit short because my iPad ran out of storage space, but it was just that water, if you remember, water has a specific heat capacity of 4.2 times 10 to the 3 joules per kilogram per degree Celsius, which is 4.2 kilojoules. Now we're going to look at our formula. And this is the formula that you're going to need to know and be able to use. Again, it's a simple formula. It works just like the last formula. Quantity of heat is equal to mass times the specific heat capacity times the change in temperature. It's three numbers multiplied together. So, let's identify what they are. Q stands for quantity of heat. Now, to be consistent, we want quantity of heat measured in kilojoules. We're doing everything in kilojoules. And M is our mass. And for consistency, we want our mass to be in kilograms. C is our specific heat capacity. And that is in kilojoules per kilogram degrees Celsius. We look here onto this chart. This is where we get those numbers. This column and this column. Delta T, again, same as before, change in temperature. Positive means the temperature went up. Negative means the temperature went down. Now you can calculate the change in temperature by taking your final temperature and minusing your initial temperature. All right, so let's look at these two examples before you get started on some questions. Number one, how much heat is needed to raise the temperature of 2 kilograms of copper from 20 degrees Celsius to 70 degrees Celsius? So I'm going to write out my formula. Q is equal to mc delta T. There's my formula. 4 variables. I need to know 3 of them, and then I can find the 4th one. So my Q, my M, my C, and my delta T. Putting them over there. Q, I don't know Q. That's what I'm trying to figure out. How much heat is needed? M is 2 kilograms. And 2 kilograms has one significant figure. Just one digit. C, that's from my chart. I'm going to go over here. I'm going to look at copper. 0.39. 0.39 kilojoules per kilogram degrees Celsius. This has two significant figures. My change in temperature. Well, I started at 20 and I went up to 70. So I do 70 take away 20 gives me a plus 50 degree temperature change. Plus 50 degrees. And this has only one significant digit, the 5. Trailing zeros before the decimal are not significant. So one significant figure. So now I've got my 4 variables. I know 3 of them. I can figure out the 4th one. So let's do that. So Q is equal to M, so that's 2 kilograms, times 0.39 times 50. And this is all in the correct units. This is kilograms, this is degrees Celsius, this is kilojoules per degree, kilograms degrees Celsius. Multiply those 3 numbers together. 2 times 0.39 times 50 equals 39 kilojoules of energy. So if I have 2 kilograms of copper and I want to raise its temperature 50 degrees Celsius, I have to put in 39 kilojoules of energy to it. Now, because this is 1 sig fig, and this is 2, and this is 1, when we multiply numbers of different significant figures together, our answer should always have the lowest amount of significant figures. So we should round our Q to 1 significant figure, which would mean it's 40 kilojoules. All right? That's how you use this formula. It is exactly the same mathematically as the thermal expansion formulas. So once you've got the thermal expansion formulas done, you know how to use this formula. Question number 2. A 1 kilogram block of aluminum has an initial temperature of 10 degrees Celsius. What will the final temperature be of the block be if 3.0 times 10 to the 4 joules of heat is added? So this, we're going to do Q equals mc delta T. That's our formula that we're working with here. Quantity of heat. We write Q mc delta T. Now we know the quantity of heat being added right here. It's 3.0 times 10 to the 4 joules. And that has 2 significant figures in it. But we don't like joules. We need this in kilojoules. Well, 3.0 times 10 to the 4, I'm just going to write it down at the bottom because I'm out of space. 3.0 times 10 to the 4. We move the decimal 4 places to the right, so it'll be 3, 1, 2, 3, 4. So 30,000. So this is equal to 30 kilojoules. So, right, joules to kilojoules is just like grams to kilograms. Mass, we know the mass. The mass is 1 kilogram. This has 1 significant figure. We know the C because it's aluminum, so we can pull out our chart, find our aluminum, 0.9. 0.9 kilojoules per kilogram degrees C. Our change in temperature we don't know. We know the initial temperature, but we're trying to figure out the final temperature. So we don't know the change in temperature. We have an equation with 4 variables. We know 3 of them. Let's put in our 3 variables. Q is 30 kilojoules equals 1 times 0.9 times delta T. Okay, so now we have a simple algebra equation. So we multiply, we simplify our right side. 30 is equal to 0.9 delta T. I multiplied those two together. Now we need to isolate our delta T. Divide both sides by 0.9. Those two will cross out. And we do 30 divided by 0.9, 33.33333. Our change in temperature is 33.3. Now this guy is only supposed to have 1 significant figure. But we never round 2 significant figures in the middle of a question. So our delta T is 33.3. Now we start at 10 degrees Celsius. So we start at 10. And then our temperature goes up 33.3 degrees Celsius. So what's our final temperature? I mean, you should be able to just figure that out by doing 10 plus 33.3. And that will get you a final temperature of 43.3 degrees Celsius. You could use this little formula right here. Change in temperature is equal to final temperature minus initial temperature. And our change in temperature is 33.3 is equal to our final temperature that we don't know, minus 10. Add 10 to both sides. And we get 43.3 is equal to our final temperature. That's in degrees Celsius. There's our answer to the question. We answered the question, what will the final temperature be? So it's a simple formula. 1 variable equals 3 other variables multiplied together. If you're given any 3 of the variables, you should be able to find the 4th. Always write out the formula first, list out your information, solve for your missing variable. Sometimes you may have to do a little bit of extra work on the side to make sure you answer the question. All right, so the end, there are 10 questions here to do. And you should be able to do them based on the examples. All right, thank you for watching.